Good day, folks. It's Tony Fortunato from the technology firm. Believe it or not, some people asked to see my mug. This is it. No AI, just the artificial intelligent part of it. So we're going to look at a trace file, actually two trace files. I'm going to show you how to capture from two different places and figure out the real response time of an application. Enjoy, folks. So this is a great example of what I always preach for the people who've been in my training sessions, my presentations, whatever you want to call them. This is what I ask people to do. Just a simple diagram. It doesn't have to be fancy like this. You can just draw it on a napkin. It doesn't matter, right? So all we want to do is capture some key parts of this exercise. It doesn't matter if we're troubleshooting or baselining. So for example, let's start at the client end. We've got his IP address. And I put a little magnifying glass to show people where we're capturing from. You can put a little fin. You can. It doesn't matter. So in my case, it's a magnifying glass, and I'm going to call the trace file client.pcapng. Sometimes I do more than one capture. So it's literally going to be client 1, client 2, client 3, that kind of thing. What are we doing? Well, it's an HTTP request. That's what we're told. We're also told it's TCP port 65020, 65020. And we're also told this is the actual PHP script that we're going to execute. And off it goes to the races. It goes into the internet box thingamajiggy. It doesn't matter what this thing is. Please don't ask. It doesn't matter. It comes out of this box and the port number changes. And it goes from 65020 to 8800. Still HTTP, which is good to know. This is what they claim. We're going to find out if it's true. Goes into the big old box we're going to call a server. It's also got a magnifying glass, means we're capturing here. The file name is going to be server.pcapng. This is the IP of the server. What does the server do when it gets this command? It sends off an RTSP command to pull a stream off a camera, builds a video file, and then sends that file via SMTP TCP port 587. We're going to find out how long this whole mess takes. Another important thing to document is how you're capturing things. It could be as simple as this. We got a screenshot of that original part that we saw a moment ago from the client's perspective, but now I've added how we've configured Wireshark to capture the packets. This is pretty easy, right? TCP port 65020, 65020. I might have also added the IP if I wanted to. I know it's a fairly unique port number. The client's not going to be using that for anything else, so I can get away with just doing that. But you should document that, all right? Document that. And usually we put that in the file comments. I'm going to show you that in a bit. But for now, this is how we set up our capture from the client side. As you can well imagine, the client part was pretty straightforward. The server part, not so much. But it's the same thing, just times 3, right? We've got this port number coming in. We've got these coming out. Again, I'm going to keep this all simple and consistent. Doesn't mean it's right or wrong. It's just the way I want to do it right now. And what did I do? Simple 3 filters, right? Port 8800 or port 554 or port 587. I like using the port command because it will capture it if it's TCP or UDP. Some protocols start with TCP, flip to UDP. Who knows? Sometimes the client's wrong. So I always like to use the word port just to cover my bases on UDP and TCP. The only other thing you got to worry about here is when you start your captures, please make sure you do them at the same time, right? That kind of thing. And this server is already recording from this camera. It's kind of like an NVR anyway, so there's going to be a lot of extra traffic. We're going to have to figure out which ones correlate to the command. So for the people who've ever attended my public sessions, classes, presentations, whatever, I go on and on about a very simple concept. Don't do anything until you have a goal, right? Don't just capture packets because you can. Don't accept a 6 gig packet capture because somebody happened to have one. Don't do anything until you have a goal. So what is the goal here? Well, the goal is the application spits this message back to the client, recording 10 seconds of video and emailing it to you, email sent. So by the time the client hits the button and gets that message, they say it's way longer than 10 seconds. Now, do they ever time it? No, they just feel it's longer than, so is it 30, 50, 60, 300? We don't know. We're going to find out how long it really takes. So let's see how long 10 seconds really is. So before we jump into the packets, I've gotten a lot of really good feedback, which I honestly do appreciate, by the way, folks. People have told me how they like the way I lay the screen out and what do I do with Wireshark before I start analyzing and why, right? So that's what I'm going to do right now. This is the default way people usually have Wireshark, and I'm not a big fan of this. I'm going to tell you why in a moment. Now, we're going to do this step by step. So if you want to follow along, please do, but it's just the way I do things. This is my MO. First thing is these colors. The colors don't mean anything to me right now. Why? Because I'm not troubleshooting. I don't care if the colors represent a protocol or an error. It doesn't matter right now. I just want to find out how things are working. So I'm going to turn the colors off. That's this colored button right underneath telephony. Click, it's gone. It's just a toggle, on, off, right? So we're going to leave it off. The other thing is these two panes here. We don't need these panes. This is the packet list, packet details, packet bytes. So we're going to turn off the details and turn off the bytes. Go to View, Details, View, Bytes. Why? Again, we just want that superficial high-level view right now. We don't need all that detail, and things look clear right off the bat. So what do we have? We have a source, a destination. We only have 7 packets, which is awesome. This is where you can always start to fine-tune your troubleshooting or baselining requirements. For example, I got a SYN ACK, I got an ACK, 3-way handshakes complete, I got a GET, I got an OK, and an ACK here. Well, I don't have the end of the conversation. I don't know if it's a fin or a reset. If that matters to you, do it again. If it doesn't matter to you, fine. Right now, it doesn't matter to me because all I did was record when the client hit the button and when the client got that message back from the actual server saying the recording was done and I've emailed it to you. So how long did this take? Well, 0 all the way down to 19 seconds. It said 10 seconds. So this is almost twice as long as what's being reported on the screen. So we're going to go to the server side and find out why. Here we are at the server, and we're going to go through a different exercise than we did on the client side. Why? Because there's a lot more going on. We have 3 port numbers, right? If you look back at that other screen, you'll see there's that port 8800, 554, 587. We're not quite sure if they're TCP and UDP. We were told they were TCP, but we're going to validate that. And again, I'm going to start with how I set things up in Wireshark and why, and we'll take it from there. Here we have our 3-pane display. Again, packet list, details, bytes, no detail, no bytes. View, no details, view, no bytes. We don't need it. Second thing, these colors, don't like them. Bye-bye. There you go. And now we need to find out what's where. Now what I did do, in case anybody wants to know how to do this, I've changed the actual IP to a name. Doesn't matter if it was DNS resolved, not resolved. It doesn't matter. You can always edit those names. How do you do it? Well, I can just right click on it, edit resolved name, and I called it camera. Okay, so it's 192.168.39.66, and now it's called camera. You just have to make sure under view, you've got your name resolution checked off for resolve network addresses. You got to make sure that's on. If it's not on, it's not going to work. All right. So there you go. So we'll see camera. We'll see some other names that'll make life easy for us. But let's move on to the next step. Now I'm going to do things totally different here. I'm going to go to statistics, conversations. So this is a shopping list of all the conversations. We're going to go all the way to TCP. Now we've already learned something, believe it or not. We weren't quite sure if all these ports were TCP or UDP. Well, UDP doesn't have a number. So there's nothing in there. I can click on it, show you, but there's no number. So it's all TCP. Good to know. So we've already validated that. The other thing is we need to figure out which one of these conversations relates to what we did. Because again, this server is in use and talking to the camera and other cameras and other stuff going on. So we want to pull our stuff out. The easiest way to do that, let's scroll here to the right. Really neat little column that you might want to look at called relative start. I'm going to actually click the header and sort it. So this is showing me the conversations as they came in over time. And you can see 000 blank 2.9. Now I'm going to try to move over so I can keep the relative start in the screen and a little bit of the port numbers. There we go. So relative start 8800. That was our HTTP request. That's good. So there was stuff going on before it that I don't care about. So 8800 is good. And then we know that it talks RTSP over 554. That's this. Awesome. And then 587 is our email. Beautiful. So I want to filter on these 3 TCP conversations. So I'm going to start with the first one, right click, prepare, selected, and I'm going to use the stream ID. So the stream ID is going to be a combination of the 2 IPs and the 2 port numbers. You can also use A to B if you'd like, but I'm going to do this. And I use prepare. Okay, don't apply, prepare. It's going to build your filter for you right here. It's going to keep building it. So next one, right click, prepare, or selected stream ID, filter on stream ID. And there it is. So that double bar means or. Last one, right click, prepare, or stream ID. So we got 3 of them in there. I'm going to close that off. I'm happy. I'm going to hit little arrow or enter. And now I'm going to get a filter on those 3 port numbers. And you can see there's our first one, 8800, and there's our get command. Awesome. And that says client because I've renamed everything, right? I could have made 3910, called it server if I'd like as well. Here, we'll do it right now. Just show you what that looks like. Edit resolve name, and I'll call this server. There you go. Done. So client server. Off we go to the races. Now this starts at 2.9 seconds. So there was some stuff before it. Remember, it's a live server. So we want to zero this out and start at this point. So I'm going to right click here, set or unset the time reference, or Control T. And you'll see there it is. If I made a mistake, again, just Control T is a toggle, on, off, right? There it is, on. So now that's going to zero it out. So the time starts now. I can see my get, I can see our TSP gets kicked off. It's doing its thing, right? Which is nice to know. And it's 3966, which is the correct camera. So it's not a coincidence. It's what we did. And that's the actual command. So if you ever have to sit down with somebody and say, hey, this command is making it act squirrely, you can show them the actual command sent over the wire. We can see the reply, so on and so on and so on and so on. At the end of all that, then we get a SYN popping out of there. 10.7 seconds later, hey, 10 seconds. That's what the script said, 10 seconds, right? But then we have the email part, SMTP, right? So off we go to the races. How long is this going to take? Well, there's a lot more to go. So I'm just going to hit the good old end key. So the end key takes us to the bottom, 19.465 seconds. And that's right at the end where we have our little resets and stuff like that. Some people might want to go before it or after. I don't care. It doesn't matter. It's pretty well 19 seconds regardless. So why did it take so long? Well, it's because you had to email that video file, and that wasn't being accounted for. The script was simply how long did it take for me to take that video stream and create the file. It did not account for how long does it take to actually email that file. So it takes 20 seconds for the entire process, or 19.465, regardless what the screen says. Obviously, the bigger the video file, the longer it's going to take. If you have a congested line, it's going to take longer as well, but that's how we do that. So I hope that helps you out when you troubleshoot stuff in the field. Have a great day, guys. Bye for now.